Look up tonight, and you are not seeing the sky. You are seeing a memory. That star just above the horizon, the light hitting your eyes, left its surface before you were born. Maybe before your parents were born. In some cases, before humans existed at all. It could still be burning right now, or it could already be gone, collapsed into a smoldering ember of degenerate matter, and you would have no way of knowing for centuries. Every single object in the night sky is a message from the past, arriving at exactly the moment you happen to look up. So here's the question that quietly unravels everything. If the sky is a record of what already happened, what does the sky look like next? Not next year, not next century. What would you actually see if you could fast forward and watch the universe live out the rest of its story? Most people assume the universe just sits there, more or less the same, forever. It doesn't. It's moving. Not the planets swinging around stars, the fabric itself. In the 1920s, Edwin Hubble pointed a telescope at distant galaxies and noticed something that shouldn't have made sense. Their light was stretched toward the red end of the spectrum, as if they were fleeing from us in every direction at once. Not just moving away, the space between us and them was expanding. That would already be strange enough, a universe that grows. But here's where things become difficult to imagine. In the late 1990s, two independent teams of astronomers pointed their instruments at exploding stars billions of light years away, expecting to measure how much the expansion was slowing down under its own gravity. Instead, they found the opposite. The expansion is speeding up. Something is pushing space apart faster and faster, and we still don't fully know what it is. We just gave it a name. Dark energy. It makes up roughly 68% of everything that exists, and we understand almost none of it. This is the part that changed how I think about space. If the expansion keeps accelerating, it means the galaxies we can see right now will not always be visible. Picture the observable universe as a bubble around us, and every galaxy outside a certain distance is already moving away faster than light itself can cross the gap. Not faster than light travels through space. Faster than space itself is stretching. Light from those galaxies will never reach us. They are, for all practical purposes, already erased from our future. Now push that forward. 100 billion years from now, an astronomer standing on a planet somewhere in the Milky Way, assuming anyone or anything is still around to stand anywhere, will look up and see nothing beyond our own merged galactic neighborhood. No Andromeda smear, no distant clusters, no cosmic web, just a lonely island of stars floating in perfect black. They will have no way of ever discovering the Big Bang. No way of measuring the universe expanding, because there will be nothing left to measure it against. The evidence will have physically outrun the reach of any telescope they could ever build. An entire truth about reality, permanently unknowable, simply because they were born too late to see it. Sit with that for a second. We are living in a specific, narrow window of cosmic history where the evidence for our own origins is still visible. Future intelligences may never get to know what we know right now. That's not a small thing to be handed. There's a strange irony buried in that fact. Right now, in this era, we can still detect the oldest light that exists. The cosmic microwave background, the faint afterglow of the universe cooling down roughly 380,000 years after the Big Bang. It arrives from every direction at once, a fossil imprint of the entire observable universe when it was still a blistering fog of plasma. Astronomers didn't even find it on purpose. In 1965, two radio engineers kept picking up a faint hiss of static in their antenna and initially suspected pigeon droppings were interfering with the equipment. It wasn't pigeons. It was the oldest photograph of reality ever taken, and it had been sitting there the entire time, waiting for someone to notice. That signal is still reaching us today, stretched by billions of years of expansion into microwaves instead of the visible light it started as. But it, too, is fading. As space keeps stretching, that ancient light gets diluted further, red-shifted into wavelengths so long they'll eventually be indistinguishable from the background hum of an empty universe. One day, even the birth of everything will become undetectable. If you're still here, and your sense of scale hasn't completely collapsed yet, you'll probably enjoy what comes next, because this is where it gets even stranger. Let's talk about the stars themselves, because they don't all die the same way, and they don't die on the same schedule. Massive stars, the bright, blue, furious ones, burn through their fuel in a few million years and end violently, some collapsing into neutron stars so dense that a teaspoon of their material would outweigh every mountain range on Earth combined. Others collapse further still, past any known state of matter, into black holes, regions where gravity has won so completely that not even light can climb back out. But the smallest, dimmest stars, the red dwarfs, are the patient ones. They burn their fuel so slowly and so efficiently that the universe, at 13.8 billion years old, hasn't existed long enough for a single one to die of old age yet. Astronomers estimate the smallest red dwarfs could keep shining for 10 trillion years. That's not a typo. 10 trillion. For comparison, if the entire current age of the universe were compressed into one single day, the lifespan of a red dwarf would stretch out for roughly 2 years. We are, cosmically speaking, still in the first few seconds after midnight. Eventually, though, even they run out. Somewhere around 100 trillion years from now, an almost meaningless number to a species that measures its own history in thousands of years, the last red dwarf will flicker and go dark. And when it does, something happens that has never happened before in the history of the universe. For the first time since the earliest stars ignited, there will be no new starlight left to make. It's worth pausing on why. Stars aren't just burning fuel, they're forging it, fusing lighter elements into heavier ones and releasing the energy that becomes starlight. But star formation itself depends on galaxies having enough loose hydrogen gas drifting between existing stars, waiting to collapse into something new. That gas is finite. Every generation of stars uses a little more of it and returns only a fraction back into the galaxy when it dies. Observational surveys suggest star formation across the universe has already declined dramatically from its peak, which happened roughly 10 billion years ago, meaning the universe's most fertile era for building new stars is already behind us. We are not living at the beginning of the story. We are living somewhere well past the peak in the long, quiet decline that follows. This is where the universe stops being a story about light and starts being a story about darkness. Stellar remnants, burnt-out white dwarfs, neutron stars, black holes, will drift through an increasingly empty void. Some theories suggest that even protons, the particles inside every atom, may not be perfectly stable and could eventually decay over timescales so long they make the age of stars look instantaneous. Numbers like 10 to the 34th power years, a figure so large it has no honest human comparison. Matter itself would slowly stop existing as matter. And the black holes, even they aren't permanent. Physicist Stephen Hawking showed that black holes leak a faint trickle of radiation and very slowly evaporate. The largest supermassive black holes, the ones sitting at the centers of galaxies, could take up to 10 to the power of 100 years to fully evaporate, a number known, almost affectionately, as a Google years. Try to picture that scale and your intuition simply gives up. It's not built for it. Nobody's is. What's left after that isn't destruction exactly. It's silence. A cold, flat, near-empty expanse stretched almost to nothing, where the rare surviving particle might drift for longer than the entire history of stars, galaxies, and civilizations combined, without ever encountering another particle at all. Some physicists call this the heat death of the universe. Not an explosion, not a bang, just a slow exhale that never quite finishes. And yet, here's the strange comfort hiding inside all of this. None of it is happening to punish anyone. It isn't a warning. It's just what a universe does when you give it enough time, which is the one thing a universe apparently has an endless supply of. The same physics that will one day erase the last galaxy from view is the physics that built every atom in your body inside the core of a star that died before the Earth even existed. You are, quite literally, cooled stardust, having a conversation with itself for a few decades before returning to the dark. So go back to that star you looked up at earlier, the one whose light left before you were born. Look at it differently now. It's not just an old signal arriving late. It's a preview. Somewhere, impossibly far in the future, something, or someone, might look up at the space where our galaxy used to shine, long after we're gone, and see nothing but the memory of light that already finished happening. Which raises the question nobody can quite answer yet. If intelligence exists anywhere else out there, right now, in this same brief window before the sky starts closing, are they looking up too? Which object out there completely changed the way you think about space? I'd genuinely like to know.